guys, so today what we're going to do is we are going to look at a word problem, and we're not only going to solve the word problem, we're going to kind of define a great general practice to do with all word problems. Okay, so again, today's learning target is that the student is proficient at the laying out and the solving of a word problem. Our problem here says a helicopter hovers directly above a landing pad on the roof of a 125-meter high building. A person is standing 145 meters from the base of the building. The angle of elevation of the helicopter from this person is 58 degrees. Assume the landing pad is at the edge of the building, closest to the person. How high is the helicopter hovering above the landing pad? Alright, so as I first look at this, sorry, bit of a technical error. As I look here, these are the steps that I'm going to follow. Okay, I am going to first read my problem, which I've done, draw the problem, so to give yourself a visual representation of what it looks like. It's a step that a lot of people skip, but is actually really important here. Because while you may know the math, if you don't have the triangle set up correctly, you may not be looking for the correct thing. Then you're going to define your variables, and we do that in a couple ways. One is to define it in words, and one is to put our variable onto our picture. Pick your strategy to solve. If you watched our last video, we talked about how to differentiate between the three strategies that we've been working on: law of sines, law of cosines, and SOHCAHTOA. Then we're going to do work. Last but not least, we're going to interpret our answer. Because as you've heard me say before, I've never walked into my boss's office, yelled a number like 42, closed the door, and had him think, "Hey, good job." It's normally, "Oh, we need 42 more calculators," or something like that. You have to apply context. So what does that look like with this particular problem? Well, the first thing we know is that we're going to have a triangle. And I'm going to do some quick sketching so you kind of really understand where the different things came from. Here's my person. And my building, the ground, and my helicopter. And my job, now that I have drawn my problem, and is to label everything I know. Well, I know that this is 145 meters, and that the building, so from here to the ground, is 125 meters. I do use units. It's important to look at that. Your drawing doesn't have to be perfect, but get an idea of where your pieces are. So if you use a P and a B and an H, that's fine also, but definitely have those pieces in there. Next, it said that our angle of elevation to the helicopter from the person was 58 degrees. When we're talking about angles of elevation or depression, we're always going to reference a horizontal line, or a line that is perpendicular to our building. So when I'm talking elevate, I'm talking go up, which means that I'm talking about this growing. And so what I'm looking at is this measure right here, 58 degrees. An angle of depression, if I were interested in that, would be based off of a horizontal line up here, and it would actually be this measurement. Okay, so depression means down, elevation means up. Okay, so here's our angle of elevation. Alright, now the next thing I need to do is define my variables. We're going to switch colors here. We're going to go to black. We're going to throw in an x right here. What I'm looking for is the distance from the top of my triangle to the roof. Another way to define that would be to say is x is the distance from roof to the helicopter in meters. And so once you have this, you really know what you're looking for. Putting this definition in words is almost like interpreting the problem just before you have the answer. And so we'll kind of see how that looks like in a second. Now, I need to pick my strategy. And we had three ways to pick a strategy the other day. Here I would use SOHCAHTOA, because when I'm thinking SOHCAHTOA, I know I need a right triangle, I need to be given two pieces of information, and those two pieces should be either a side and an angle, or a side and another side. In this case, you have an angle, right here, and a side. And we do indeed have a right triangle. We're always going to assume a building and the ground are at a right angle with each other, unless otherwise stated. So now I know I'm going to use SOHCAHTOA. I have to look at my angle and the two sides that I have or that I'm looking for. So I have this angle, and across from this angle is this side. And while I have part of this side, I don't have the whole side. So this is kind of what I'm looking for. Down here, I have this side. This is our opposite and our adjacent. And so that's going to give us our tan 58 equals 125 plus x over 145. Careful, this is not 125x. That would be taking this and multiplying it by that, and we don't want to do that. We want to just add the two lengths together. 145 was my opposite side here. And so now, my next step is to take and multiply both sides by 145. Once I have multiplied both by 145, I'm going to put this directly into my calculator, and I suggest doing it now. Because if you subtract this 125 before you put it in your calculator and try and do it on the same line, a lot of times people will mix up where their parentheses go, or maybe they'll try and subtract 125 from there, and we don't want to do that. When you put 145 tangent of 58 in your calculator, you get 232.049. In my class, if I don't tell you where to round to, we always round to the third decimal place as far as lengths go, and to the nearest whole degree if we're talking degrees. Now I have a very simple equation. I subtract 125, and I get 107.049. As I look at this right here, this is my last step. This is where you would get an answer that is appropriate. The helicopter is 107.049 meters above the landing pad. If someone wrote above the building, that would also be okay. So again, just to review quickly, our steps for solving a word problem will be to read the problem, draw the problem, label everything we have, define our variable, define our strategy, do the work, and interpret the answer. That is the best and most sound way that you can solve these word problems that we were looking at that are applications of our trigonometry in the room.